All right, so we're gonna go ahead and start working with confidence intervals again. This is for a population mean. So I'm gonna go ahead and read this. It says, in this lesson, we learn to construct a confidence interval for a population mean. This uses an estimate, which is a sample mean, and we need its margin of error. Steps for making a confidence interval for a population mean. That's a typo right here. Okay. So what we have to do is gather a sample mean. We're going to need a sample size. We're going to need sigma, which is impossible. It's the population standard deviation. You're not going to know that, so we'll fix that later. You're going to need a level of confidence. Okay, I think that's good. The step really should be gather and check. Okay, the checking is to verify that you can use a normal distribution. And we know the central limit theorem says the distribution of sample means is approximately normal if the sample size is bigger than 30, or if the population we're sampling from is normal. So you need one of the two so that your sample means are normal. So check that n is bigger than 30, or population is normal. You got to have one of those. Okay, or it doesn't, or the empirical rule doesn't imply anymore. Sorry, the empirical rule doesn't apply anymore. And now you can't say that 90% of the time your statistic will be within 2 standard deviations or 2 standard errors. And so your margin of error is no good, right? So normality is critical. Population doesn't need to be normal, but the sample means need to be normal, and that's always true if you can get your sample size bigger than 30. Okay. Anyway, so you look up the z alpha over 2 on table A2. That's our new table. And just to remind you how the table works. You can use table A1 as well, but it's not very good. There's a degrees of freedom here. Just go down to the bottom row where it says large. Okay, those are the z-scores which you want. The rest of them are t, which we'll talk about later today. Our alpha is whatever it is, but just make sure it's under 2 tails. Okay, and then down in the bottom row, you'll have that z alpha over 2 value. Okay, margin of error we already gave. It's z alpha over 2 times sigma over the square root of m. Endpoints of the confidence interval are just x bar plus or minus the margin of error. So you write the interval like this: x bar minus error less than the population mean now. Remember, we're trying to estimate a population mean. And that should be between x bar plus or minus the margin of error. And you say that we are blank % confident that the mean of some population is between, oops, that's a little bit too many e's, is between blank and blank. You should include units there. And that's it, okay? So let's do a quick example here. You've got 75 adult men. Already I can say on my check, my n is 75, which is greater than 30, so I'm okay there. So M is 75. And their mean height is 68.5. That's a sample mean. X bar is 68.5 inches. And assumed population standard deviation is sigma. It's 2.7. No way in the world you'd know that. Nobody has surveyed the height of all men, but we're pretending here. There's a confidence level of 0.94, which means our alpha is 1 minus that. It's a complement, so 0.06. Getting a little messy. I'm going to clean that up a bit. Okay, 0.94, so you get 0.06 for alpha. And then when you go to table A2, again for degrees of freedom, which will be more clear later, you just say large, where those are z-scores. Okay, alpha is 0.06. Make sure you're looking, sorry, my bad. 0.06, make sure you're looking under two tails. Okay. And I have no idea what this is, so we go to table A2. I'm going to pull that up real quick. Let me erase the last one because this is different now. Okay, so with a 0.062 tail, that's this down here. And then you just got to go to the bottom row of the table all the way down. Okay, and I see a 1.881 down there. Okay, any questions about that? I think this table is at the end of your handout. Okay, 1.881. Oops, wrong thing. This is so easy. You just go from there to your margin of error. So the error is z alpha over 2 times sigma over the square root of n. So the z alpha over 2 is the 1.881. Standard deviation was 2.7 over the square root of n, which was square root of 75. Yeah. I do that all in one shot on my calculator. Just type a whole thing in. Let's see, the mean has one place. So let's do two places after the decimal. Anybody? 0 point something. Are you there? Are you guys out there? Five, 8, 6, yeah, I want to do two places. With the means, remember, we kind of carry one more place than what we're given. This has got a 2.7 here, so that's one place. I'm going to go two places, 0.59. Okay, and so for our confidence interval, x bar minus e less than mu less than x bar plus e. So the x bar was the 68.5 minus the margin of error, which is 0.59. So it's a 67.91 on the low end. And on the high end, just add them. So you should get 69.09. That's still probably too precise, but remember these are inches and it's the mean height of men. So then I'm 94% confident. So we are 94. It's a kind of a silly level of confidence, but it allows us to sort of just practice on these different confidence levels. So we are 94% confident that the mean height of men is between 67.91 inches and 69.09 inches. Okay, just like that, simple. Okay, any questions? There's another one on here, so we'll practice it also. So this one says the mean final exam score for a random selection of 250 of my stats students. Okay, right off the bat, we've got our check. N is 250, just needs to be bigger than 30, and that guarantees that the sample means will be normally distributed. And just like that, the normal distribution is super important. Okay, so I've got my check accomplished. The mean is 76.5, that's your X bar, 76.5. And it says I need a population standard deviation. It says it's 12, so that's sigma. The population standard deviation is 12. They want a 99% confidence interval, so the confidence is 0.99. Alpha is 1 minus 0.99, so that's 0.01. Okay, going to our table, we need the Z alpha over 2. So for degrees of freedom, again, this is table A2. Okay, for degrees of freedom, scroll all the way down. For large, those are Z scores down there. The alpha is 0.01 two-tail. Okay, and I think that comes out as, could someone look that up? Yep, thank you, Wenjing. It's 2.576. Oops, 76. So your margin of error is Z alpha over 2 times sigma over the square root of n. Again, we're sort of pretending here that you could know the population standard deviation. Later, we'll use the sample standard deviation, but it causes problems. So we're doing the easy part first. 2.576. Sigma is 12. And then it's over the square root of your sample size, which is 250. Okay. Oops, 250. Sure. And again, I think I like 2 places because my mean has 1, so I like to increase the accuracy by 1. Anybody? Hey, Jay Zarko, oh, I see what you guys are telling me. That's the margin of error, 1.96. Good job. From Matthew and Benjing and Jay Zarko. Thank you guys all. So don't forget, there's a confidence interval next. So that's just the margin of error, which usually is all people want to see. You know, you're off by 1.96 points on the average. That's your maximum error. But we like to do X bar plus or minus the margin of error in stats. Give a range of values. It's sort of a little more honest. I don't know what it is. It's somewhere between here and here. Okay, the X bar was 76.5 and you're subtracting 1.96 and adding. Okay, I'm going to clean that up a bit. Okay, so I got 76.54 on the low end. And on the high end, we add those. So let me get the upper limit on this. Yep, that's the low. Anybody get the high? 75.54. Uh-oh. So I got 74. Let me check all my numbers. 76.5 minus 1.96, 74.54. I think I'm okay. Upper limit is 78.46. Agreed. I think that lower limit's okay. So, ooh, except for maybe I wrote it wrong. I wrote it wrong. I see what you're saying. 74.54. Thanks for that, Matthew. Correct again. Okay, so again, the conclusion, you just have to say the mean is between those, and you're only 99% confident. So we are 99% confident that the mean exam score is between 74.54 and 78.46 points. That's it. Easy. So easy. Okay. The confidence intervals are all the same, and they're not a problem. Just, when I provide the formulas, I'll provide the tables. Make sure, the biggest mistake people make is they don't know how to use the table. Okay, and that's a little bit of a problem, obviously. All right, so I don't know if you remember, but when we were wrapping up the proportions, the last thing we did was we said, well, what if that margin of error is too big? What if you want to bring your margin of error down? And so there's a pretty simple relationship between error and sample size. It is that the error is this z critical value times sigma over the square root of n. So we're trying to solve for the sample size, so we'll multiply both sides by the square root of n here, and we'll divide by the error. And so you can see that those sample sizes cancel on the right, and the errors cancel on the left. Okay, so now I've solved for the square root of the sample size. So that's the z alpha over 2 times the standard deviation of the whole population. You'll probably estimate that with a sample standard deviation, and then you divide by this error here, the margin of error that you're picking now. And then we want to square both sides because we're interested in the actual sample size. So we'll have to square that. Okay. And so the sample size is the z-score times the population standard deviation, which you'll estimate, divided by your margin of error, and then the whole thing has to get squared. So this is a little different. We would sample at least this many You're choosing your margin of error. So you just put whatever they pick for the margin of error down there. You're going to have to round this to a whole number, round up to a whole number because the terms are at least. Got it? So you would round up. What is going on with this thing? To a whole number. Okay. That's it. Okay. So in the previous example, it's saying, well, what sample size would we need to get a maximum error of 1 point? Okay. So this guy here tells me the sample size for a chosen margin of error. I think I'm still doing, oh, did the confidence level change? It did. So here our alpha is 1 minus 0.98 this time, not 99. So this is a 0.02. Okay, so going back to table A2, for the degrees of freedom, again, you go all the way down to large. Those are, again, z-scores. But our alpha is 0.02, and again, 2 tails. Okay, all the way down. This goes all the way down to the bottom row. I think we've done that one. Not 1.96. I can't remember what it is. It's 2.33 maybe? I don't know. So let me bring that table up. 0.02, 2 tails. Did anybody do it? This is wrong. 0.2, 2 tail right here, all the way down. Yeah, 2.326 down there. Okay. Let me bring that back. 2.326. If they change the confidence level, you got to change your critical score. So 2.326 times the standard deviation, which is 12, I think. And then the margin of error, they're just choosing one point for the margin of error. You square that. Okay, so this will be a larger sample size because they wanted a smaller error. Okay, so in parentheses, put in the 2.326 on your calculator. Don't need to divide by 1, just multiply by 12. Close the parentheses and then square that. This is a good example because remember we have to round this up to a larger number. So before you round it, what is it? Anybody? It's a big one. Good. So, but be careful. You have to round this up. So it is a 779. And if you say 0.08, that's fine. Remember, this is a number of people or a number of test scores, which has to be a whole number. And the keywords here are at least this many, which means you're going to have to go up to 780 because you can't do 0.08 people or 0.08 test scores if you want. So you're going to go with 780 on this. And yes, I'll give credit for 779. That's fine. But if you're being picky, it's 780. Okay. So are there any questions about that? So that's if you want to get your margin of error down. Pretty straightforward.